Hi friends, welcome back to Punsirol Science. Today I am going to explain you about the basics of electric circuit part 1, and I hope this lecture will be very much useful for those who are reading in class 10 and class 12 science. This tutorial will cover introduction to electric circuit, active and passive components of a circuit, difference between DC and AC current, concept of node, branch, mesh and a loop, calculation of branch current, concept of short circuit and open circuit, and sample do-it-yourself problems. If you are watching this video for the first time, please subscribe to Punsirol Science and press the bell icon. Then let's go to the tutorial directly. What do you mean by electric circuit? An electric circuit is defined as a closed path comprising of conducting wires, energy sources along with other active and passive components. Energy sources provide potential difference needed for the flow of charges in electric circuits. Well, what do you mean by active and passive components? Active components generate or amplify electric power in a circuit. Battery, AC generator and transistors, etc. These are examples of active components. Passive components neither generate nor amplify electric power, but they either absorb or dissipate electric power in a circuit. Resistors, capacitors, and inductors are examples of passive components. These are some of the passive and active components used very often in electric circuits. Now let us see the difference between direct current and alternating current. Direct current is a steady current. Direct current never changes its direction if not altered physically. Alternating current is an oscillatory current. Alternating current changes its direction automatically in every half cycle of oscillation. We can express DC and AC as function of time. This figure shows graphical representation of DC and AC. For DC, current is a constant function of time. For AC, current is sinusoidal function of time. In case of DC, the direction of current depends on polarity of the battery connected to a conductor. In case of AC, current direction changes automatically. Positive current and a negative current shown over here represent current passing through a conductor in opposite direction for both AC and DC. DC is said to be a steady current because current does not change over time. In case of AC, current changes over time in a periodic manner. That is why AC is known as oscillatory current. Since AC is an oscillatory current, it has frequency of oscillation and time period of oscillation. Frequency is given by number of complete cycles per second. One cycle is equal to sum of a positive half cycle and another adjacent negative half cycle. Time period is given by time taken to complete a cycle. AC signal shown over here can be drawn by using this mathematical equation. I is a function of time equal to I naught multiplied by sine of 360 degree multiplied by small t divided by capital T. And frequency is given by reciprocal of time period measured in hertz. Time is measured in second. I naught is the peak amplitude of the current. Since AC changes over time, there is a transition point between positive half cycle and negative half cycle. That point of transition is known as zero crossing point. In one complete cycle of oscillation, there are 3 number of zero crossing points. Now an important question is, does direct current have frequency? The answer is no. DC does not have positive and negative half cycles as it is unidirectional. Frequency of oscillation is 0 and time period of oscillation is infinite. And equation of DC current is I of t equal to I naught. Now let us see what are the sources of electric current. DC generator, rectifier and battery produce DC current. AC generator and inverter produce AC current. A rectifier converts AC into DC. An inverter converts DC into AC. Now let us see the direction of direct current in these two circuits. In the first circuit, the current is circulating in the clockwise direction, and in the second circuit, current is circulating in the anti-clockwise direction. In the first circuit, X is connected to positive terminal of the battery and Y is connected to negative terminal of the battery. In the reverse manner, positive terminal is connected to Y and negative terminal is connected to X. Therefore, current passing through these two circuits are in the opposite direction. This shows that direction of DC current can be changed only by reversing polarity of battery in the circuits. Alright? Now what about the direction of alternating current? AC current changes its direction automatically in every half cycle of oscillation. During positive half cycle of the AC signal, the current is circulating in the clockwise direction. During negative half cycle, the current is circulating in the anti-clockwise direction. In India, the frequency of AC signal is 50 Hz for domestic applications. Therefore, current direction will change 100 times during 1 second. Now let us see a simple DC circuit. In this circuit, there are 4 resistors, 1 battery, some connecting wires, an on-off control switch, and a reference point. Now let us see the concept of node in a circuit. A node is defined as the joining point of active or passive components in a circuit. In this figure, A, B, C, and D are known as node of the circuit. In between node A and D, an active component is there. Similarly, in between A and B, another passive component is there. And D is known as reference point or common point or ground of the circuit. Now, what do you mean by reference point of a circuit? Node voltages are measured with respect to reference point. This point is also known as common point or ground of a circuit. Its electric potential is 0 volt. Remember, ground or reference point always lies in the current return part of a circuit. Current generated by the voltage source is going away from the positive terminal of the battery. Then, it passes through different components of the circuit and finally it returns back to the negative terminal of the battery. So this part is known as current return part. Now you try to examine whether these two circuits are equivalent or not. In fact, they are equivalent. You are getting the second figure from the first one by removing the redundant nodes. Now let us see the concept of branch in a circuit. Any current carrying path lying in between different nodal points of a circuit is known as a branch. In this circuit, AB, BC, CD, BD, and AD, these are branches of the circuit. Now let us see the concept of mesh in a circuit. A closed loop which does not have an internal loop is known as mesh. In this circuit, ABDA, BCDB are known as mesh of the circuit, whereas the bigger loop formed by joining A, B, C, D and A is not a mesh. We will see the reason in the next slide. In this circuit, there are 3 loops, 2 small loops and another bigger loop. Smaller loops are known as mesh because they do not have internal loop. The bigger loop is not a mesh because it contains the smaller loops. Alright? Let us see the concept of positive and a negative node voltage. Remember, node voltages are measured with respect to ground or the reference point or the common point of the circuit. As you see in the first circuit, common point is connected in between negative and a positive terminal. Whereas in the second circuit, the common point is connected in between negative terminals of the battery. Accordingly, this circuit is equivalent to this, where across the resistor, positive 5 volt is there and negative 3 volt is there. In the second case, across the resistor, positive 5 volt is there and positive 3 volt is there. Alright? Now let us try to find out current passing through a resistor by using Ohm's law. Here is the original circuit and here is the simplified equivalent circuit. Ohm's law says that current passing through a conductor is directly proportional to the potential difference across the conductor. Now here, across the conductor, in one side there is plus 5 volt, in the other side there is minus 3 volt. So if you apply the formula, current is given by Bx minus of By divided by R plus 5 volt minus of minus 3 volt divided by 10. Then you got 0.8 ampere. Now this is another circuit which is similar to the previous one. but the potential difference is not the same as earlier. So here the current is 0.2 ampere. And let us see one more circuit. In this circuit, the equivalent circuit is obtained in this manner. Here the potential difference is 10 volt because in this side the potential is 0. So you get I equal to 0.1 ampere. Now let us see the concept of short circuit and open circuit. Short circuit part will have 0 ohm resistance. Open circuit part will have infinite ohm resistance. And as a warning, you must remember that positive and negative terminals of the battery should never be short circuited. If there is a short circuit in between them, there will be a very large flow of current which may damage the battery. In this circuit, the bulb is able to glow. Now let us see what happened to the circuit after a short circuit. Now we have sorted node B and node D. After that, bulb is not able to glow, and this circuit is now equivalent to this circuit because resistance is 0 ohm in the part BD, and current will try to follow the least resistance path. Let us see the effect of open circuit. If an open circuit has been made in between node B and node C, this bulb will not be able to glow, and accordingly this circuit is now equivalent to this circuit. In the open circuit, there is infinite resistance, so current cannot pass through infinite resistance. That is why the bulb is not able to glow. Up to this point, you have learned the basic fundamentals of electric circuit, and by watching this video again and again, you should be able to solve these problems. The first problem is find the number of nodes, branches, loops and a mesh in this circuit. Find the number of mesh and a loop in these circuits. Apply Ohm's law to find current passing through 1 kilo ohm resistors. Positive and negative terminals of a battery should never be short circuited, while on-off switch and connecting wires should have 0 internal resistance, while every closed part of a circuit is not always a mesh. Explain with an illustration. Why do electric circuit need reference node? Distinguish between active and passive components of a circuit. Why do electric circuit needs energy source? Distinguish between AC and DC current. Represent AC and DC current as a function of time. Draw the symbol of DC and AC voltage sources. Mention the sources of AC and DC current. And if you find this tutorial useful to you, please subscribe and press the bell icon. And also, please do not forget to share this video with your friends. Thank you all.